The software architecture axiomatization, or I call it actually axiomatic software architecture, I have presented recently at International Conference on Software Architecture in Denmark. And the reason why I called it axiomatic software architecture, I didn't call it, for example, axiomatic design for software engineers, is that I do believe we should not use axiomatic design in the detailed design of software. Detailed design of software should remain based on algorithmic design. But axiomatic design could be used actually in the high level of software architecture level design. Therefore, I wanted to emphasize this by choosing this title. So, but my presentation, I'm going to actually focus on three criticisms that exist about axiomatic design, using axiomatic design in software engineering field. And the first one is about the functional domain. So I will talk about it shortly. The second one is about agility of this framework. And then the third one, which is, I call it implicit criticism, because people often tend to show it by doing that criticism rather than by writing it down. And what I mean is that people often miss process domain in the software systems, while process domains are as equally important as other domains. And we shouldn't miss them, otherwise we will end up in infinite design loop. And I will show this what I mean by this. So let's start by this. So uncertainty in defining functional requirements. This criticism is actually regarding to functional domain. So empirical evidence shows that it is not feasible to accurately identify the correct functional requirements and constraints before beginning coding activities. And this criticism actually is quoted back to Friedrich Barks, who basically in his book talked about why we should be ready to throw one system away. And I kind of find myself in disagreement with this criticism because, number one, Borg's idea goes back 50 years ago, on the time that we actually were mostly on ontogenetic design, meaning that we were basically designing software systems for very first time. So we didn't know how to actually design software systems. So 50 years ago. Nowadays, most of software systems are being phylogenetic design because we already either have existing software system and we are modifying it, or we redesign it. Number two reason is that actually when Barks talks about prototyping, I have a different interpretation. I think he means we need to use prototyping to have good understanding how design parameters should be chosen. It's not about uncertainty on functional requirements, it's about uncertainty on design parameters. And of course, if I cannot define high-level design parameter, then I will end up in low-level functional requirement uncertainty, which is a measure of complexity, I would say. So therefore, if I cannot define what should be the high-level design parameter for the high-level, very first level functional requirement, then I cannot zag again into functional domain and define sub-functional requirements. That means I will be in the uncertainty of defining sub-level functional requirements. Uncertainty of defining sub-functional requirements means complexity. And as Nampisu says in his book, actually, in the introduction of complexity, although AD represents a systematic and scientific method for designing complex systems, including softwares, it is not actually meant to answer questions like what is complexity, or how to reduce complexity, or how to tackle the uncertainty that I have in functional requirements. That is not the goal of axiomatic design. Axiomatic design is a design framework. We should not have such expectations that design framework will basically solve our uncertainty issue. Therefore, in my experience of almost more than 15 years of developing software systems, there was no single time that I could start developing a system without having the highest level functional requirement. Highest level functional requirement is always over there because need is over there. But sub-level functional requirements They might enter into uncertainties, that's right. But that is not the topic of axiomatic design. That's a topic of complexity theory. So, agility of axiomatic design. The AD process is relatively straightforward, but requires a slight departure from many iterative focused design processes. Or, the design rules of agile development are somewhat conflicting with the guidelines of axiomatic design. I think it might be not so straightforward to use axiomatic design in an agile way, but it is not that bad. So, what I mean first, agility does not mean design without understanding functional requirements. Whenever in my team we started doing sprint planning and bring our backlog item into the development phase without understanding what is the functionality that we want to provide, we failed. That is not agile. And the second is that, by definition, each functional requirement is independent. If functional requirements are independent by definition, then I should be able, in principle, to take one functional requirement and take it to the design, all entire process. I can do vertical, horizontal iterations as well, because functional requirements are supposed to be independent. Therefore, if I face problem, there are two possibilities. Either functional requirement wasn't independent, therefore I'm not able to continue the design because I need another functional requirement. As Nampisu says, we can combine these two functional requirements and make it one. Or I have an uncertainty in design parameters and I need prototyping. Let me give you an example. I take one customer need and then I take the highest level functional requirement. Then I go with the design parameter and I go with the process variable. Then I came back. I decompose that high-level functional requirements based on the design parameter, and then I only start with one chain. What I mean by one chain, the first iteration I will go with developing the lowest level FR1 and the lowest level DP1. Second iteration, lowest level FR2, lowest level DP2. This third iteration, and like this. So this is basically the iteration. So, and every time I might see that, okay, actually when I implemented design parameter 1, this somehow satisfies also FR2. Then over there's an issue regarding independence axiom, and we can talk about this. I have only 2 minutes, so I will just move on. The second thing is that why process variables are important. Look, imagine I do not use process domain and I have a business need. I want to control a boiler. A boiler is difficult. If you have ever wrote a logic for PLC based on IEC 113161, writing logic for a boiler is complicated, it's difficult, but it's not complex. So I take this, and if I want to write that logic needs to be continuous process, right? In control process, we have discrete continuous. It needs to be continuous. The next level functional domain that I will, functional requirement that I will define is that, okay, to writing a real-time control process, I need real-time operating system. For real-time operating system, then physical domain will be real-time scheduling algorithm. Then, look what happened. I was going to design control system, but I ended up in designing operating system, real-time operating system. Why? Because I didn't consider process domain. If I consider process domain, then real-time operating system is in fact a material that I'm gonna use during my design. That is gonna be, for example, VxWorks, a real-time operating system. So this is why Nampisu says that libraries or operating systems or even compilers are process domain, this stuff, process variables. If I take that, then now I can basically unblock my way and I can go with control process domain. The next is that is not operating system, it's actually controlling process 1, process 2, process n in real time. And for each process, physical domain will be PID1, PID2, PIDn. So, thank you so much. My presentation ended. This is my LinkedIn. If you want, we can stay in contact. If you don't want, we can still be in contact. So, any questions?
And I wonder, how do you factor in uncertainty when you cannot prototype?
So,
because not always you can prototype.
Yeah, actually the thing is that prototype, proof of concept, is a way of dealing with uncertainty.
Yeah.
But if you cannot prototype, then what also I like from Nampisu is that it says do educated case. That's what we do, and industry we do. You think that I can give you very concrete examples in industry that we develop products by guessing what would be the requirement. And that's a method that we use even in system design. Sometimes in algorithms we do that. We guess that the next instruction that could be executed in microcontroller will be, for example, instruction 10. We go there. If we fail, we will come back. But if we didn't fail, we succeeded. That's normal, and it works in all basically stage of engineering. But prototyping is the first step of answering uncertainty if uncertainty is in the design parameters. But if you have an uncertainty in functional requirement or the customer needs is not clear, that is not the topic that we need to discuss under axiomatic design. That's a topic that we need to discuss under complexity. That means, for example, the doctor doesn't know how to cure a illness. Here, design framework will not help the doctor. So doctor has uncertainty. Over there, we need to. This is what also actually Chicago from 1960 has papers, and he worked on this, and he has the idea of building knowledge base. So this is what you need to build a knowledge base to encounter with this issue. Or Canadian framework by David Snowden actually also works on that area, that how to do, in uncertainty to make decisions. These are better answered in different fields rather than axiomatic.
Chris. Thank you. That was interesting, and so many interesting points brought up. And we should discuss this. What do we do when we can't make a prototype, and how do we deal with uncertainty? There's lots more there that we can talk about. My question is, do you ever do this? Because when I end up seeing, oh my goodness, this design parameter solves 2 FRs, the next question that I ask, and I want to know if you ever do this, is, are those really 2 separate FRs? Did I define the FRs correctly? Or if I can solve them and I'm happy with the solution, do they really need to be 2 independent things?
Exactly. That's a very good point, right? I also do the same. Some months ago, in Deloitte office in Amsterdam, I was helping people to design a sustainability project for calculating food footprint. And what I noticed was that people often either were misunderstanding the constraint and taking constraint as a functional requirement. This was resulting in defining more functional requirements. Because if you want to control a constraint in the design by defining functional requirements, then you have to define different functional requirements, right? Or they were actually mistakenly, they were not realizing that why these functional requirements are even independent from each other. For example, there was a functional requirement. The person needed to basically have a save button to create a new entity. But if this new entity was being created for first time, then had to go through different state. If it was the second time, the same save button had to behave differently, because if you push the save button for first time, then the system should assign a code to that element. But if it is the second time, the system should do actually update, not create a new. You see, 2 functional requirements, independent functional requirements, are gathered into one design parameter. And the question is, why even they should be? Because this was adding complexity over there, that you needed to develop some, different mechanism to understand, okay, is the user first time doing, is the second time doing? That's a very good question.
So there's also physical integration and keeping things functionally decoupled. But thank you. I think
maybe one from my side. So if we are talking about complexity theory, also in axiomatic design, we know that there's the real complexity, then there's the imaginary complexity. Imaginary, we can solve it by using axiomatic design because we can better understand the system. and therefore it's easier also to handle the system. Then we can have time-dependent complexity, where we have always the issue that next year maybe things are changing, and therefore my system design maybe
periodic time dependent, not in
right, and
combinatorial.
therefore we have the differentiation. Is it a combinatorial one where I have really a very complex system, or can I solve it with periodic function, with functional periodicity? So I can redesign and reinitializate, or having a trigger point where every 2 years or every week I need to restart and reprocess. And we had in our research also that problem with the triple bottom line, so economic and sustainable, as well as then also the human-centric part, where we have seen also this kind of uncertainty and complexity based on this multidisciplinary approach. So we, for example, we are trying now to do it in the first step with axiomatic design for structuring and understanding the department, and afterwards with Simulink, MATLAB, then to use a uncertainty-based MDO approach, so multidisciplinary design optimization. So what is your...
So basically, what is my understanding is that the complexity theory that Sue started working on it, and has a major departure, by the way, compared to other complexity definitions, because Sue doesn't define complexity in physical world, defines in functional domain. When you define in functional domain, then you have the information axiom. And information axiom is actually creating the foundation for the complexity theory, because I have the system range, design range, and I have the probability of success. And this is basically the foundation for the complexity theory that Sue is working on.
So we're then with the candidates of solutions, then seeing which one has the best probability of success, using then different methods for design optimization. I think it goes then in this direction. Because that's then where we need then to do the prototyping for having then a decision, or we are doing buying algorithms.
I would say that's a bit different topic to my belief. Maybe we can discuss in detail, because prototyping is not always about answering the uncertainty. Sometimes we also prototype while we are certain. So therefore, prototyping while, to my belief, always is a good way that helps us to basically overcome to this uncertainty issue, but it's not always meant for that purpose. So therefore, yeah, prototyping could be used, but there are also sometimes that minimum viable product is the way to go. Because by minimum viable product, you can delay architectural decisions. And as much you delay architectural decisions, design decisions, as more you gain knowledge about the system and about the custom, about the business, then you can make more accurate decisions.
Thank you. Due to time reasons, again, we need to go forward, and thank you very much for your presentation. And the next one is now from Professor Laurentius Latinian from the IASI University in Romania, and he will talk about how to apply axiomatic design